previously we took an example of structures where the lowest priority group was on the plane up. Let's now take another case where the lowest priority group is either on the right or on the left, still on the plane, as should be drawn by a solid line. So something like this. So this is the lowest priority group, of course, as determined by atomic numbers. If that's number 4, something like that, then this is, if this is number, let's say 1, for example, and that's 2, and this is 3, just an example. Now, let's take also the mirror image in order to discuss it along with this specific mirror image. If we draw the mirror image of this structure, then we should be able to get something like this. So this is group of priority number 2, and that's of priority number 3. And remember, the bottom line or the rule is to view the molecule so that the lowest priority group is away from us, or it's at the back or at the rear, if you like. So it's in a way, so it's like not, it's unseen, and then we end up with 3 groups, and then we check the rotation. If rotation is clockwise, then it's an R configuration. If rotation is counter-clockwise, it's an S configuration. Now, the way to look at this molecule is, if we take this structure, the way to look at this molecule with this specific structure, or with this specific orientation, if you like, is to look at it so that the sight is away, or the viewing the molecule is opposite to number 4. So this is the direction, if you like. So this is how we should look at this structure. That's again the eye. That's the direction of vision, if you like. We need to look at the molecule so that the lowest priority group is away from us, or completely opposite to our way of viewing, if you like. Now, if you do that, so it's like a model, something like this model, for example. Yeah, if group number 4 is shown in blue, so that's number 4. The one shown in yellow is number 1. This is green is 2, and red is 3. So remember, this is 4. So this is where we should look at opposite to 4. Remember, blue is the lowest priority group. We need to look at the molecule in a direction that is completely opposite to 4. So if we look at 4 now, so it's like unseen. Again, we end up with something like a steering wheel. So what do we end up with? Well, what we end up with is something like this. So this is 2, this is 3, and that's 1. Again, this is 4, this is 1, this is 3, and this is 2. So it's 1 and 2 and 3. 1 and 2 and 3. And if you check rotation, it is counterclockwise, and it is therefore an S configuration. So this is an S configuration here for this specific enantiomer, if you like, or for this specific chiral center. Again, to repeat this is the lowest priority group, number 4. This is 1, this is 2, and that's 3. We always look at the lowest priority group from an opposite direction. This is number 4. We look at it, or we should view the molecule, or we look at the molecule at the opposite direction. So that's basically, that group is at the back. Now this is 1, this is 2, and this is 3. It's 1, it's 2, it's 3. Number 4 is unseen, if you like, or invisible. So it's 1, 2, 3, and therefore it's counterclockwise rotation. And therefore, the absolute configuration is S. If you do the same exercise here, now this is the other enantiomer. So this is group number 1. That's group number 4, and this is 3, and this is 2. So again, we need to look at the molecule. Sorry, so that, well, blue, if we consider blue to be number 4, then we need to look at the molecule so that the lowest priority group is away from us as viewers, if you like, or opposite to 4. So we have 1, and we have 2, and we have 3. So it's something like that. Again, that's 4, that's 1, this is 2, this is 3. So we have 1, 2, 3, and therefore this is actually clockwise rotation, and it is R, something like that. So 1, 2, 3. Number 4 is invisible or unseen. That's exactly actually the bottom line. So if we convert that into another drawing similar to what we did before, then we get something like this. This is number 1, this is number 2, and that's number 3. And if you check rotation now, 1, 2, 3, and this is clockwise, and therefore this is R. So the absolute configuration of that mirror image is actually R. If you look at these absolute configurations, it's S and R. These two are actually enantiomers. They are mirror images which are non-superimposable on each other, and it's actually reasonable for their absolute configurations to be opposite to each other. So that's another case or another drawing of, if you like, another case where the lowest priority group is on the plane, but not up as we did before, but this time it's either on the right or on the left. The bottom line is to view the molecule so that the lowest priority group is at the back in order to determine the absolute configuration, whether it's R or S.